Welcome to Eye to the Sky, the UFO Synopsis. Now here's your host, Dee Andrews.
And welcome to Eye to the Sky, the UFO Synopsis on the UFO Paranormal Radio Network, also broadcast live on UPRN 105.3 New Orleans. I'm your host, Dee Andrews, and tonight my guest is Dr. Jeffrey Bennett. I need to let everyone know also that you can listen to this network on your cell phone by calling 704-631-4060 and entering this 4-digit station ID code 2899. My guest tonight is an astronomer, teacher, and author who holds a BA in biophysics and an MS and PhD in astrophysics. He has taught at every level from preschool through graduate school and may well be the only person to have written leading college textbooks in 4 distinct subjects: astronomy, astrobiology, mathematics, and statistics. He is also author of one previous book for the general public called On the Cosmic Horizon, and of the award-winning children's books Max Goes to the Moon, Max Goes to Mars, and the forthcoming Max Goes to Jupiter. Through his Max Goes to Schools science literacy program, he has donated his children's books to more than 10,000 public elementary schools. Among his other major endeavors, Dr. Bennett served 2 years as a visiting senior scientist at NASA headquarters, where he created numerous educational programs for the Hubble Space Telescope and other science missions. His latest book, Beyond UFOs, is available through his website, through Amazon.com, or through major book retail stores. Dr. Bennett will be speaking at the MUFON 40th Annual International Symposium, being held in Denver, Colorado, August 6th through the 9th. And I am pleased to welcome Dr. Bennett as my guest this evening. Boy, you're a busy man.
Well, thank you very much for having me on your show. I appreciate it.
Well, I appreciate you joining us tonight. I could say just before we started that I have a copy of your book, and unfortunately I didn't get it soon enough to get it finished. But what I have read on it is very good. We can get into that a little bit later. But I would like to know, you know, in your preface, you talked as a child imagining aliens and whatnot, and was wondering if what got you started into the sciences?
Well, I think what got me started into the sciences was the Apollo program, because I was a child in the 60s, and so the excitement surrounding going to the moon was really the big thing that was influencing my life at that time. And of course, it's quite astonishing that we're about to come on the 40th anniversary of the Apollo moon landing in a little over a month on July 20th this year. It seems like we haven't done a lot in the past 40 years compared to where it seemed like we would be at this point back when I was a kid.
I agree. I watched all of those moon missions myself. I was fascinated by them. And you were saying in your preface that you worked with several people to write collegiate textbooks on astrobiology. In your education background, in my opinion, kind of uniquely qualifies you to work on such an undertaking.
Well, I think I was very fortunate that I was in a position to do that. I actually don't have a particular background in astrobiology, but I do have an undergraduate degree in biophysics. And so along with my graduate work in astronomy, I was in a pretty good place for taking on a new subject area in terms of what I would teach to students and so on. So I worked with a couple of very well-known experts in astrobiology, including Seth Shostak from the SETI Institute, and we put together this textbook that is now the most widely used textbook for introductory courses in astrobiology.
And from what I understand, that's also in its second edition?
It is in its second edition at the moment. That's correct.
gosh, I'd like to get my hands on that and read through it. I probably wouldn't understand about 90% of it.
It's aimed at non-science majors, so I think you'd understand it just fine. But one of the main reasons I wrote Beyond UFOs was because even though the textbook, I think, is understandable to non-science people, it's meant as a textbook that you're going to be studying over a period of 15 weeks in great depth. So I wrote Beyond UFOs largely so that I could give people who wanted to get a taste of that but weren't going to have the time to study for 15 weeks like that, give them a taste of the same ideas, but at a level that would be something you could get through in hopefully just a few hours of reading.
I agree. I wish I'd had more time this week to really get into it and read it all the way through. What I have read so far is, I was just planning on just kind of skimming through it. But the more I read into it, the more I go, this is interesting. I don't want to quit reading. For example, your first couple of chapters is I hate to say bare bones history of astronomy, but you really go back and start from the very beginning.
Well, I think one of the amazing things when we're talking about the subject of extraterrestrial life is there seems to be this tendency to believe that it's a modern idea. And I think when you go back and realize that people have actually been thinking about this topic for at least 2,000 years, and in fact that people a couple thousand years ago, some people at least, were totally convinced that there had to be other worlds with other life forms on them, it just helps frame your perspective as you start to think about the subject and about what it's going to take to get the final answers to these questions.
Exactly. Gosh, you go through, the Greeks and all the way up through Kepler and Copernicus and all the well-known names, and even a few that I'm going, who is this person?
Yep. And all of those well-known people were thinking about this question of whether there is life elsewhere in the universe. So it's been a question that's been on people's minds for a very, very long time.
And then showing the progression of going from the idea that the Earth was the center of the universe to slowly going, we're not the center of our solar system. Oh, we're not the center of our galaxy, and progressing from there, and how all of that came about, I found really fascinating.
Oh, thank you. And, I think that one of the fun things about writing this book, Beyond UFOs, for the general public that was different from when I worked on my textbook was that I was able to talk a little bit more about some of the philosophical implications that go along with the subject and these ideas. And I don't know if you've reached this point in the book yet, but one of the things I talk about quite a bit is what I call center of the universe syndrome, which is behaving as though you still think you're the center of the universe, whether that's as an individual or whether that's the way we as a species are treating each other or our planet. And one of the things that I think is so important about this subject and the search for extraterrestrial life is that once you start to realize there's a good chance, maybe even very likely, that there are many other civilizations out there in the universe, you realize that to think of ourselves as the center of things doesn't make sense, and to behave as though the universe revolves around us doesn't make sense. So I'm perhaps being a little bit naive, but I really do think that if everyone thought about these issues, we could see better planetary behavior and better agreement between nations and not have so much hatred and war and other things in the world.
Very well said. I agree with that thoroughly. At the time of reading this, we hadn't found many Earth-sized planets yet. And since then, I believe we found one or two. I've kind of lost track here lately, but
we're not quite at Earth size yet. We're getting closer to that Earth size detection, but it's a very, very difficult detection with the techniques that have been employed over the last 15 years to find other planets. Those detection strategies make it much easier to find much larger planets. And the really exciting thing going on right now is the Kepler mission that was launched in March, because that is using a strategy where it's looking for what we call transits, where the planet passes in front of its star and causes the star's light to dim very slightly as it does so. And the Kepler is really the first mission that should be able to detect Earth-sized planets. And it will be collecting its data over the next 4 years, and I expect we will find by the end of that time that we'll have found numerous Earth-sized planets with that mission. One of the things to remember about why it takes so long is that stars vary naturally, and so if you see a star dim a tiny, tiny amount, and we're talking about like 1/100th of 1%, if you see a star dim like that once, you really have no way to know whether it was because a planet passed in front of it or just because it naturally varied that way. But if it repeats that dimming at regular intervals, say once a year over the next 3 years, you know that you've detected an Earth-like planet that's orbiting in 1 year.
This is true, and then for, say, a Jupiter-sized planet, you would see a bit of a wobble in that solar system sun.
That's the way that we've been detecting these larger planets. With the Kepler mission, the Jupiter planet would be detected the same way. It would just make a greater impact on how much it makes the star dim. So you still have the case that bigger planets are easier to detect than small ones. But Kepler is sensitive enough that it should be able to detect the small ones as well as the big ones. So when scientists do a statistical analysis on this, and you make some guesses about how common planets are, Kepler is looking at about 100,000 stars, and we expect that over the next 4 years it'll discover something like 1,000 or so Jupiter-sized planets, and perhaps 30 to 50 Earth-sized planets.
Oh, and I was doing a little bit of skimming, just going through little snippets of chapters here and there in sections that I hadn't quite gotten to. You had said in, I believe it was chapter 8, that you believed that there were, here it was chapter 8, possibly 100 billion habitable worlds in our galaxy. Do you still stand by that number?
I do. I think that it's very likely that that's going to turn out to be the case. And actually the big test of this belief of mine is this Kepler mission, because if there are that many, then it should find these 30 to 50 Earth-sized planets over the next 4 years. If it finds none, or only a couple, then I would have to revise that number downward. If it does find that many, then that number will look very solid, because statistically, if there's 100 billion of them out in our galaxy, then Kepler should find 30 or so.
Interesting. In your opinion, what would be the possibility of life on, well, say, a planet a quarter or less bigger than Earth with a heavier gravity?
Well, if the planet is smaller than Earth, then its gravity is going to be weaker. And generally speaking, we think that having a planet the size of Earth is probably very important to finding life. And there's a couple of reasons for that. The main one is that we think in order to have life, you probably want to, at least life on the surface, you need to have an atmosphere. And the moon does not have an atmosphere, and the reason is because its gravity is too weak to hang on to gas that it might have released in the past. And so a planet that's considerably smaller than Earth probably cannot have much of an atmosphere. But if you're up to the size of Earth, even Mars, which is about half the size of Earth, Venus, which is 95% the size of Earth, then you're in that range where you expect to have an atmosphere. And at that point, I think if you're in the right orbit so that you have the right temperatures, liquid water, I think life seems very much a good possibility to me.
Interesting. I appreciate that, because I've always wondered what would be the difference between a larger planet with a greater gravity than Earth.
Right, if you get too big, If you get too big, then you stop being a rocky planet and you start to become a gas planet like Jupiter, Saturn, Uranus, and Neptune. So that's why at a very large size, you don't have solid surface. You've got no place to stand, no place for oceans, and so on anymore. At very small size, you can't hang on to an atmosphere. So it's that intermediate range that looks good for atmospheres, water, and life. But that intermediate range is fairly wide. In our own solar system, out of the 8 official planets, 3 of them, Earth, Mars, and Venus, are in that right range of size. So that suggests that getting planets of the right size probably is not rare. It's probably pretty common.
Okay, out of these 100 billion possibly habitable worlds, just your gut feeling, how many of those do you think have some kind of intelligent life?
Well, I think,
like primitive.
Let's start with the primitive. Let's start with the primitive life, because I think that's the easier question to address scientifically. And of course, we don't know the answer, because the question is, if you have a planet that has conditions under which life could arise, like Earth did 4 billion years ago, the question is how likely it is that you actually get life if you have those conditions. So what I'm saying is that I think there's probably 100 billion worlds that have had those conditions. Now, you can get into a great debate over the likelihood that at that point you actually get life. My own guess, but I do have to emphasize that it's a guess, is that if you have the conditions, you're going to end up with life. So I think it's probably likely that there's 100 billion worlds with at least some form of life on them out there. But until we actually understand how you get life from chemicals, and we know a lot about that from laboratory experiments and from studying the conditions on the Earth and what could arise under those conditions. We know a lot about it, but we can't put the whole sequence together yet. But I think that the direction things are going, it looks like we're going to find out that if you have the right conditions, life will probably arise. So therefore, I think it's very likely that we have 100 billion worlds with life in the galaxy. Now, going from some kind of life, we're talking about primitive life, bacteria-like stuff, to intelligent life is a much more difficult step, and you can tell that just by looking at the history of Earth. On Earth, life arose very quickly after Earth first formed. That's part of the reason I think it's probably easy for life to arise under the right conditions. But then it took 4 billion years until intelligent life arose. And so that suggests that getting intelligent life is a much, much more difficult step than just getting life.
Interesting. I watch a lot of educational programming on like History Channel, Discovery Channel, that sort of program. And it amazes me to find out all the various locations on Earth where there's some kind of bacterial life that survives in conditions that you wouldn't think it were possible, such as in ice. Out in this desert in South America, is the least amount of rainfall on the planet, using salt to get moisture. 2.5 miles under the surface of the Earth, in mines, they have found bacterial life. It seems like everywhere you go on the planet, you find some form of bacterial life.
That's right, and I think that's been one of the great biological discoveries of the past 3 or 4 decades, has been that life is really living under a great range of conditions that, maybe 40, 50 years ago we would have said, oh, nothing could survive under those conditions, and we find that it is. And actually, when you really go through all the conditions that we find life living on Earth, the only common factor that seems to be an absolute requirement for life is liquid water of some form, but can be in microscopic amounts, as you find in the rocks or in the ice and so on. But you do need that liquid water, and so based on that, it seems that anywhere else that we can find liquid water, you would guess there's at least a very good chance that you might find life. And that's interesting even from the standpoint of our own solar system, because we know that Mars used to have liquid water on its surface, and it seems very likely, although not yet proven, that Mars still has liquid water in some places underground. So life on Mars, therefore, seems like a real possibility, and that's why NASA is working so hard to search for it. Jupiter's moon Europa, we're very confident, 95 to 99% confident, that it has a deep ocean of liquid water under a solid ice surface. So therefore, that seems like another place where you might find life in the solar system. So there could be lots of life even here in our own solar system, although we're talking, again, about just very primitive life, not about intelligent life.
Here in our virtual auditorium in Paltalk, we have a very interesting question for you.
Mm-hmm.
Tall Dwarf would like to know, in a large-sized planet such as Jupiter, why does it form as a gas giant, and what causes it to form that way?
That's an excellent question. Well, our understanding of how stars and planets are born is that they form from big clouds of interstellar gas, and as gravity collects the material together, at the center of the cloud you get your star, and in the outskirts you get material condensing into little solid pieces, kind of like rain or snow condensed from clouds on Earth. And then as those pieces grow bigger, their gravity can pull in more stuff. And what we know about interstellar material is that the gas in interstellar space is 98% hydrogen and helium. All the rest of the elements make up only about 2%. And what that means is that as you're forming that material, your solid seeds are going to be made from that 2%. So you're going to get the rocky cores like a planet like Earth, and you'll have the same thing starting out with a planet like Jupiter. But as it gets bigger, if it gets big enough, its gravity will draw in that 98% hydrogen and helium gas. So once you get big enough for your gravity to start pulling in the gas that's around you, you are automatically going to become made more and more of hydrogen and helium, because that's what most of the universe is made of.
And isn't Jupiter kind of on the verge of being just short of a star, just lack that so-called
It's not
spark?
Super close. It's about 80. It would need to be about 80 times as massive as it is to be a star. But yes, in terms of composition, the composition of Jupiter and the composition of the Sun are almost identical. They're both 98% hydrogen and helium. So the reason that Jupiter is not a star and the Sun is because Jupiter's gravity is not strong enough to make its center hot enough for nuclear fusion. If you just piled on 80 times as much material, then that gravity would make the center get more compressed, hotter, and it would become hot enough for fusion, and it would be a star. But it is about 80 times as much mass that you would need. Unless you
always
compressed
wondered
it
that.
like Arthur C. Clarke did in 2010, if you recall that book and the movie 2010.
Yes.
So that was his idea there, was instead of piling on more mass, you could imagine aliens with a technology that could just squeeze it until the center got hot enough for fusion.
I always thought that would be interesting to have a little solar system inside another a bigger solar system.
Well, there are
Jupiter.
about half the stars that you see in the night sky are actually binary star systems with two or more stars. And in many of those cases, it is like that, where the largest second object, rather than being a planet like Jupiter, is big enough to be a star itself. So that's quite common.
Wouldn't that be interesting to have, very little nighttime, most of the time having, one or two suns up?
That's right. You recall, I'm sure, in the Star Wars movie, the planet that Luke Skywalker is from has the two suns in the sky.
Oh, you know what? I never really paid much attention to that.
Yeah, you should check it out. It's done very nicely. It's very realistic to what it might look like on a planet that was orbiting two suns.
Going a little further into this, in our solar system, you already mentioned Europa. Now, personally, I'm like you. I think there might be something in the liquid water underneath the outer shell of ice. how many other moons, I think, we might be able to consider Mars possibly with a possible underground water for bacterial life. But how many other moons in our solar system do you think that at least a bacterial form of life might exist?
Well, you need that liquid water, and so in addition to Europa, we have evidence that Ganymede and Callisto, which are also moons of Jupiter, there's evidence that they also have subsurface oceans. So in that case, you've got those three moons of Jupiter that could all potentially have life in their oceans underground, assuming those oceans are real. When you go out to Saturn, you have Titan, which probably also has a liquid ocean somewhere deep underneath it, but it's also interesting because on its surface it has lakes of liquid methane and ethane that we've been learning about just over the last couple of years with the Cassini mission. And I think, maybe 4 or 5 years ago, the list would have stopped there with those four. But then Cassini discovered these jets of ice spray coming out from the moon Enceladus, which orbits Saturn also. And that is a much smaller moon, and the spray coming out of it indicates that it seems likely that there's also liquid water underground on that relatively small moon. And that came as a big surprise. Now, that's probably the only other moon out to Saturn that could have that. But then you go out to Uranus and Neptune, which we haven't had an orbital mission to yet, and it's possible that they could have more moons that also have an Enceladus-like subsurface liquid. So we've got at least 5 cases of moons in our solar system, plus Mars. So that's why I like to say there's at least 6 places in our own solar system where there seems at least a reasonable possibility of finding life. And maybe more, because we haven't been able to study the moons of Uranus and Neptune yet.
Oh, I was just received another very interesting question. This one's from Gossamer 777. And he asks, they have found several gas giant exoplanets that seem to be orbiting very close to their respective stars. Do you feel that for a solar system like ours to form, that gas giant planets need to form farther out in the solar system, like Jupiter and Saturn in our own solar system?
Another excellent question. When we look at our understanding of how stars and planets form, solar system formation, we're pretty confident that gas giant planets like that only form in the outer solar system, the way we find them in our solar system. So then comes, how did they end up being close to their stars the way we see them in these other systems? And what we think happened is that the planets formed much farther out, but then they have gradually migrated inward due to some sort of friction with the surrounding gas or various other dynamical things that can happen as we model the formation of solar systems. So one of the big questions right now is how often do the conditions allow those planets to migrate inward like that, and how often do they stay in the outer solar system the way they did in our solar system? And that's a very important question when you're looking at the possibility of finding Earth-like planets and life, because if a planet like Jupiter migrated inward to get very close to the sun, it would probably disrupt the orbit of an Earth-like planet. So those solar systems in which the Jupiter-like planets have migrated inward are probably not very good candidates for finding Earth-like planets and life anymore. But we don't know yet how common that is, and the reason is because those current detection techniques, looking for the wobble and so on, make it way easier to find those cases where the planet's in close. As we get better statistics from the Kepler mission in a few years, we should be able to say, okay, that happens only 5% of the time, or it happens 50% of the time. We'll have a better handle on that, and that'll help us understand the prospects for Earth-like planets.
Well, I'm getting questions left and right from our virtual auditorium. This one's from Gem Light, and Gem says, my son has a question. What is Dr. Bennett's favorite nebula?
I think if you go to one of my favorite websites is the Astronomy Picture of the Day, and they show different nebula photos. At least once a week they've got some beautiful one. And it's hard to choose a favorite because so many of them are just so beautiful to look like. But certainly the honor of most photographed and most famous would go to the Orion Nebula. So that's certainly a gorgeous one.
Personally, I kind of think the Ant Nebula is kind of amazing to me.
Mm-hmm.
Oh, and also, it's funny you should say that of the NASA site. That's my website of the week on my homepage for my program.
I check that every day. The pictures are so beautiful on that site.
Oh, and a little note that on there, Jem's son is 11.
Great. My son will turn 11 next week. So.
Oh, well, tell him happy birthday from us to Eye to the Sky and all our listeners.
Thank you.
And here's another one that is in my opinion, is a good question. This one's from Tall Dwarf, and he asks, is there any good possibility the moon is a towed-in, put-in-place body?
Well, that's the kind of thing that you can never really rule out, but we do think we have a pretty good handle on how the moon formed and why it's in the orbit that it's in right now, and that's the leading hypothesis for the formation of the moon, is that early in the solar system's history, a very large object, something probably that would have been a planet about the size of Mars, hit the Earth, blasted out the outer layers of the Earth, and then they went into orbit around Earth, and then they condensed back to form the moon. And the evidence for that comes from studying the composition of the moon, which matches very closely the composition of the outer layers of Earth. So, you can't rule out some other explanation because we can't go back and see exactly what happened, but based on the evidence, that seems to be the most likely way that the moon formed.
Oh, I about 8-9 months saw a program on the moon, and it was telling the different theories that had come up on how the moon got to be where it is and how it got to be and all this, and there were some pretty interesting ideas.
Mm-hmm.
Okay, getting back to your book, which again I'm finding fascinating. I believe in chapter 3, you had stated that you were skeptical, now getting into the UFO end of it, that you were skeptical of the idea of crashed craft from other planets here on Earth.
Correct. I am what I like to call myself a UFO agnostic. I think it seems very reasonable to me that we could be getting visited by aliens. But I think that scientifically there are some things we can say about those aliens if they are visiting us, and that's why I titled Chapter 3 of Beyond UFOs. The title of that is What I Know About Aliens. And what I know about aliens is that if they are in fact visiting us, and again, I think it's quite likely that they are, if they actually are visiting us, they are coming from other stars. And I can say that because we've studied every planet in our own solar system enough with spacecraft now to know that there's not been any other civilizations here in our solar system. So if they're coming here, they're coming from another star system. And the stars, then you have to say, so how far away are they, and how advanced would the aliens have to be coming here? And I go through in that chapter 2 different sets of arguments. One set based on the distance to the stars that is just enormous, and I love to work with scale. And I think, as you mentioned, I worked on the building the Voyage scale model solar system that's on the National Mall in Washington, D.C., and there we use the sun as about the size of a grapefruit. Earth on that scale is about 15 meters away, and it's about the size of the ballpoint in your pen, and Pluto's about a third of a mile away. And on that scale, to go to the nearest star, you have to cross the United States. And on that same scale, the distance to the moon is only a little over an inch. So you're talking about aliens who essentially can go across the United States when we've only been able to go 1 inch to scale. So their technology would have to be incredibly amazing. The second line of arguments I go through is the time argument, because the galaxy's been around for a long time, long before Earth even formed. And I won't go through the details with you right now, but my conclusion is that on average, just taking reasonable numbers, you would expect that any civilization that's traveling to us now would have to be at least 50,000 years ahead of us technologically. And so I like to go back to Arthur C. Clarke's famous quote that any sufficiently advanced technology is indistinguishable from magic. And so I think we can make a very strong case that if aliens are indeed visiting us, as far as we're concerned, their technology is so advanced that it's magic. And therefore, if somebody tells me, hey, they just crashed and left metal pieces, I think, we don't even use metal in our advanced aircraft anymore. We're using new composites. What's the chance that a civilization 50,000 years beyond us would be using metal? They'd be using something that we wouldn't even recognize. So that's why I'm skeptical of those types of reports. When somebody tells me they saw something that they couldn't identify, now that makes sense to me. I'm not saying that I necessarily believe it, but it makes sense because a very advanced civilization, if they don't want us to see them, they can probably do a really good job of hiding. But maybe every once in a while we catch a little glimpse.
You also used the an analogy of the safety of airline travel.
That's right.
And I found an interesting statistics here. On any given day, there are approximately 80,987 takeoffs per day worldwide. That's a lot of flights.
That's right.
And I have a list here going from 2000 to 2008 of number of airline accidents per year. For example, in 2000, there was 179. In 2001, 187. 173 in 02, 198 in 03, and on up to last year, and it slowly but surely starts dropping off to 2008 to 147.
Right.
Now, that's not just crashes. That just says just number of accidents.
Right. That's just incidents. The number of crashes is much smaller, right? That's correct. Yeah, we have made air travel incredibly safe already. And that's why I say give us another 50,000 years of technological development, and we'll make it basically foolproof. So that's why I think anybody who's able to come here probably isn't going to crash.
Well, just to be the devil's advocate, so to speak, here, since I do a UFO-related program.
Yep.
A counter argument, so to speak. Anything that's manufactured can fail.
That's correct. That's correct. So I cannot rule it out on that basis. So it could be that they could crash. But in that case, it would be wonderful to find the evidence that everyone would agree on that proved, no one would be happier than me to see real evidence that they've been here. And but I think that if the evidence looks like metal, it's probably not the right evidence. If we find something else, then, and I know that's the kind of stuff you've been working on, then that would be terrific.
And I love it that you are, like you said, an agnostic, kind of a fence sitter. Because there's a few aspects of the UFO subject that I'm on the fence as well. Such as you pointed out in, I forget which chapter it was, but the possibility of aliens using crop circles to communicate. Mm-hmm. That, to me, that just sounds so ridiculous to me.
Yeah, it's always possible. It could even be their idea of a cosmic joke. But if they really wanted to give us a message, they could come up with a more convincing way to do it. They would have to be very, very smart, yes. And I think another important thing to remember is, I think oftentimes scientists are portrayed as being at odds with people who believe in UFOs, but I don't think that's the case at all, and that was one of the reasons why I wrote the book and titled it Beyond UFOs, because I think scientists are inherently interested, and many are studying this question of whether there's other life out there, and people who I think who have gotten interested in UFOs have that same interest. And I think that, science tends to go about things maybe in a different way sometimes than other types of pursuit, but it doesn't mean that we don't have the same interests. And that's why I think that it's a lot of fun when we can all get together and say, okay, maybe somebody says they believe in a UFO thing and somebody else says, I'm not so sure about that, but there's still things about this subject that we can all look at together and say, yeah, we can all agree, wow, there's probably a lot of habitable worlds out there and probably a lot of places with life, and we can all agree that sending up a mission like Kepler to try to actually establish that that's not just a belief but is actually a fact is a really great idea, and it'll be really great to see its results.
Something I've always wondered, in our galaxy anyway, where in the galaxy do you find the older stars? More towards the center, or off on the rim, such as where we are?
That's an excellent question. When you look at a picture that represents our galaxy, of course we can't take a photo of our own galaxy since we're inside it, but we know that it's a spiral galaxy like these other spiral galaxies that you see photos of. And when you see a picture of a spiral galaxy like that, what you're seeing is what we call the disk of the galaxy. It's the flat part that has the spiral arms. And actually, in that disk, you find stars of all different ages. There's some very old ones, and there's some very young ones. What you don't see is the big spherical region that surrounds that flattened disk, what we call the halo of the galaxy. And that's actually where you find the very oldest stars, the globular clusters and so on. And the reason for that, we think, is very simple, that just like we talked about stars forming from clouds of gas, galaxies, we think, originally formed from much larger clouds of gas. So as those clouds were collapsing, very early on, there were some stars that formed before the cloud finished collapsing, and those are still out there in that halo. But the rest of the gas collapsed down into the disk, and that's the only place where stars can still form today. So in the disk, you get stars of all ages. In the halo, you have only very old stars.
Oh, another interesting question here from a member of our virtual auditorium. This one's from Russ Mack. And the question is, in binary star systems, is there not generally too much of a temperature variation on planets in that system? And I'm assuming on the chances for life on planets in a binary system.
Another excellent question. Actually, the real question there is not so much about temperature, but it's the question of whether you can have a stable planetary orbit. If you can have a stable planetary orbit, then the temperature will be whatever it is, depending on how far it is from one or both of the stars. And again, until fairly recently, most scientists assumed that it would be very difficult to get a stable orbit in a binary star system. But then when scientists started to model it more carefully and look at, what are the possibilities, it turns out that actually it's not that hard. You have a couple of different cases that you can think about. For example, in one case, imagine that the stars are pretty widely separated, like maybe imagine that Jupiter was a small star with 80 times its current mass. It turns out that even though that would put a second sun in our sky, it would have very little effect on Earth. It's far enough away that Earth's orbit around the main sun would still be pretty stable, and it's also far enough away that it wouldn't be providing all that much heat to Earth. So we might still be a pretty good place for life, even if Jupiter had been a star. Another case is the case of the Luke Skywalker's planet in Star Wars. There you have the two stars are very close together, so the planet orbits around them almost like they're a single star. So you have many possibilities, even in binary star systems, for still having stable orbits and planets that could, in principle, be habitable.
You must be a big Star Wars fan.
I love those movies.
I do too. I grew up on Star Trek and.
The new Star Trek is definitely my favorite. I really enjoy it.
There's another very good question here. This one again is from Gossamer. I'm hoping I'm not mangling this individual's name up too bad, but I believe it's pronounced Ragbir Bathal, who is an astronomer in working with the astrophysics department at the University of Western Sydney, Australia.
Oh, great.
Who is also a member of SETI. But instead of looking for radio waves, he's looking for laser pulses. Have you heard of this gentleman, and what do you think of his approach to finding ET signals in the form of laser pulses instead of radio signals?
I don't know him personally, but that is one of the important areas of research with SETI. And with SETI, what we're trying to do is we're trying to find a signal that someone might be sending out into space. And we've been searching mostly for radio signals for a long time, or not that long, for a few decades. And that's because radio signals have been the easiest ones to search for. But there's not necessarily any reason to think that aliens would use radio. Why not laser pulses or something else? And so the more we can search, the better our chances of finding anyone who is broadcasting out there. And I'm very happy that SETI has been able to start looking in other parts of the spectrum, because that's an important part of the search. So it's fantastic work that they're doing.
This just kind of popped into my head, and I hadn't thought about even discussing this, but for communications from, say, some alien civilization spacecraft out there somewhere trying to communicate back at home and not wanting to wait like a year or two for the reply. In watching Michiko Kaku on several programs, he mentions the different dimensions and wormholes and whatnot, going between the dimensions. What would the possibilities be of using an artificial wormhole to transmit a signal?
Well, that's a great question. I mean, of course, the difficulty is we don't really know whether that's possible to create or not, and whether you could use it. So that's where we're talking about very, very advanced scientific knowledge, and if it's even possible, about incredible technology to do something like that. What we do know is that if you're using any form of ordinary light, whether it's radio waves, infrared light, visible light, lasers, ultraviolet, then it's limited to the speed of light. Certainly, if you're a super advanced civilization, if something else is possible, then it's quite likely you'd be using that. And sadly for us, if you're using something that we can't even say whether it's possible or not, that means we probably can't detect it right now. So one of, I think, the hopes of SETI efforts is that civilizations out there are, in fact, still using technologies that we're capable of detecting. There certainly would go through a period in their history when those would be the technologies they would use, just as we are. The question is, how long? Will we still be using that same technology in 1,000 years, in 10,000 years? Or will we have discovered something that right now we can't say anything about? So those possibilities that he talks about, and the same possibilities they use in Star Trek, for example, where they try to at least stay within the realm of scientific possibility, those are just things that really scientifically right now all we can say is maybe. We can't say yes or no.
Oh, here's another good question from Russ Mack. On the subject of physics, claiming it is impossible to travel faster than the speed of light, is not the universe expanding faster than this?
That's an excellent question. What relativity actually tells us is not that nothing can go faster than the speed of light. It tells us that you can't send a signal through space faster than the speed of light. And I don't have time to go into the details of that, but you can pick up any book on relativity. I actually have a couple chapters about it in my astronomy textbook, The Cosmic Perspective. But basically, it's almost a definitional thing. It turns out what Einstein discovered was that, we tend to think of space and time as absolutes and speed as variable, but it's the speed of light that is absolute and space and time that vary in response to that. So it's not a matter of technology or anything else. It's a matter of the true nature of the universe, that you can't go through space faster than the speed of light. However, That doesn't mean space can't expand faster. It doesn't mean, something couldn't be moving away from you faster than the speed of light. It just means you couldn't ever send a signal between you and that other object, at least not through space. Then if you have wormholes, if you have hyperspace, that opens up other possibilities too.
I always think of hyperspace, subspace, whatever terminology you want to use, for getting from one star system to another. It's obvious, the technology we're using. For example, going back to the Apollo moon mission, it took 3 days to get from Earth orbit to the moon?
A couple of days, yep.
And that's only 250,000 miles. I mean, that's, like you said, just an inch compared to the vastness of just our galaxy alone.
Yep. Yeah, one of the reasons why this hyperspace idea is so fascinating and people really enjoy it is that you have to remember what it means. Hyper means beyond, right? And space is three-dimensional. So hyperspace is just a shorthand way for meaning something beyond our ordinary three-dimensional space. And Einstein's theory of relativity already tells us that space-time, our universe, is really four-dimensional, not just three-dimensional. And it seems reasonable to imagine that there could be dimensions beyond that. In some of the theories of everything that you may have heard about, superstrings and so on, they talk about 10-dimensional spaces and so on. So that's where these ideas of perhaps there's a way to circumvent Einstein's prohibition on traveling through space, because that's pretty much an absolute prohibition, that you can't go through space faster than the speed of light. But if you leave space, go into hyperspace, there doesn't seem to be any rules about where you come back in or when you come back in. And that's why they use it in Star Wars. In Star Trek, they do basically the same thing, but they warp it through hyperspace rather than they call it a different name. But it's the same idea.
Oh, gosh. It's just the idea of being able to go from one world to another has always fascinated me and always wondered how man would finally conquer that distance. It's like going from chariots to the modern car.
It's much more than that, actually. Yeah, when you actually look at the numbers, it's much more than that. It's an incredible feat that we would need. We're nowhere close to that technology today.
And on that note, perfect timing. It's time to go to a break, and we'll be back here in 8 to 9 minutes here on Eye to the Sky, UFO Synopsis on the UFO Paranormal Radio Network.
Welcome to Eye to the Sky, the UFO Synopsis. Now here's your host, Dee Andrews.
And welcome back to Eye to the Sky, UFO Synopsis, here on UFO Paranormal Radio Network, also broadcast live on UPRN 105.3 New Orleans. I'm your host, Dee Andrews, and tonight we've been talking with Dr. Jeffrey Bennett. Dr. Bennett, going into the SETI program, you said earlier that you're a member of SETI, correct?
No, I'm not a member of SETI. I mean, yes, I pay my dues to the SETI Institute to be, a general member, but I'm not one of the SETI Institute's researchers, no. But my co-author on my astrobiology textbook, Seth Shostak, is one of their researchers.
Gosh, how do I explain? Spit out this question running through my head. The project has been going, since Arecibo was constructed, which I forget how many years ago that was. But
before that, actually, 1959, I think, or 60 was the first search.
Oh, that's right. With what was it, Big Ear? Wasn't that what they called it?
Ozma, I think, was the name of the project. Yeah.
And a lot of these have been looking for radio signals. What do you think the possibility of finding a signal in amongst all that background radio noise throughout the entire galaxy?
Well, it's a very good question. I think that certainly if a signal is being sent, we should be able to distinguish a deliberate signal from the background radio noise. So I think that part of it is in principle, not that difficult, although we haven't had the technology to search for it really carefully and systematically until very recently. And the new Allen array that they've built up there in California, the SETI Institute, really is a big step in that direction. But I think one of the issues that you have to understand right now with SETI is what we are capable of detecting. Now, we ourselves are broadcasting signals into space in the form of radio and television, right? That's going out into space at the speed of light. So if any star within, 75 light years of us or so can listen to our old TV and radio broadcasts going back up to 75 years in principle. But when you look at how strong those signals are, the further away they get, the weaker they get because they're spreading out over a greater volume of space. And so our current SETI technology is not capable of detecting somebody's radio and TV broadcast from another star, where they're not anywhere close to being sensitive enough for that. So the only kind of signal we could detect right now is a signal that's so strong that for us it would have to be something that we have deliberately beamed out into space. So what we're really hoping is that there's other civilizations out there that are, in fact, deliberately sending out signals in hopes that someone will hear them and is also deliberately beaming out signals that they may hear. And, I think it's quite reasonable to think that other civilizations are doing that. We certainly think it's worth looking for others, so there's every reason to think that other civilizations would have the same interest. So if everybody's broadcasting at some point in their existence, then those signals are out there in space, and the only question is any of them coming toward us right now?
You mentioned the fact that we here on Earth are constantly broadcasting signals from all over the planet, radio, television, shortwave, all that. Since today is the first day of digital TV, what is the difference between a digital frequency and the frequencies that analog TV was broadcasting on? And could that difference also be a similar difference between the radio signals we're picking up from out in the interstellar space and a possible digital signal transmission?
I'm not up on the details of the frequencies being used, but basically you can use any frequency you want to broadcast either analog or digital. It's just a difference in the way that you're encoding the data. And so if somebody is sending a signal to us that is an intelligent signal, it doesn't matter whether it's analog or digital. Either way, it should be clearly distinguishable from background noise due to natural sources. So I don't think that would have any real effect on things. If somebody's doing it on purpose, they will have something in there that we should be able to identify. Whether one of my favorite books and movies of all time is Carl Sagan's Contact, and there, of course, they encode it with prime numbers so that we can recognize that pattern of prime numbers, which would not be coming naturally from any source. It would have to be coming from an intelligent source. So that would be the way that we would recognize it. And there might be other ways that we could recognize it too, but clearly a deliberate signal would be different from natural background.
I love that book. I read it. It was awesome. And I have even visited the Very Large Array in New Mexico. And
Great sequence in the beginning of that movie, isn't it?
Yes, it is, where she's sitting out there with all those dishes. They're out at the very large array there in New Mexico, and it was amazing going there and seeing. I've been past there many times, and you see them all bunched together or spread out. I believe it's 13 miles is
something like that. I don't recall the exact
spread.
Number.
That idea behind that whole story. Now I'm going by the book, not the movie. It was very, very interesting.
Yep.
Rusnak in our virtual auditorium has come up with another good question. When the Drake equation was originally hypothesized, how many more or less civilizations would be calculated now, given the abundance of the planet discoveries in other star systems?
That's an excellent question. I think that the Drake equation, you can't really calculate anything with it because we don't know the values of any of the terms in it. And for people who might not be familiar, the Drake equation is just a way of putting together the terms that you would need to know in order to know how many civilizations are out there. So I like to use a modified version of the Drake equation, which is a little simpler than the original, and Frank Drake himself has given it his blessings. We used it in our textbook. And but you start with the number of habitable planets. You multiply that by the fraction of those that have life. You multiply that by the fraction of those that have the life become intelligent life. And then you multiply that, the fraction that become intelligent civilizations, and then you multiply that by the fraction of them that are out there right now, as opposed to a billion years in the future or a billion years in the past. And that tells you how many civilizations could be broadcasting at us right now. The main difference today from when Frank Drake first wrote the equation is that number of habitable planets, at that time, we had no actual evidence that there were any other planets anywhere in the universe besides our own solar system. Today, we now know, because we've discovered these hundreds of planets already, that other planetary systems are common. We don't yet know how common the habitable ones are, but again, I think with the results from Kepler a few years from now, we will probably be able to say that number of habitable planets, I think we're going to find is up in that 100 billion range. So we now can get a handle on that first number that we couldn't get back when he was doing the work. There's other parts of the equation also that we have a better handle on. For example, what is the fraction of habitable planets that actually get life? We still can't say what the answer is, but we know a lot more about what it takes to go from non-life to life now than we did when he wrote that equation down almost 50 years ago.
Wasn't there an update done to Drake's equation done by, I can't remember the gentleman's name, here just a few years ago that his answer came up with a bit smaller number than Drake?
Well, I think, again, at least among scientists, the equation's never really been used to come up with a precise answer. It's used to try to understand what we need to know in order to come up with an answer someday. And as far as I know, the only alternative version of the equation is the one that we've developed in my textbook, and that I talk about in Beyond UFOs. And it's really the same equation. It's just put into somewhat, I think, simpler terms for students to understand and for the general public to follow.
Okay. That makes sense. A lot of sense. Excuse me. On the subject of UFOs, I believe it was in your preface or the first chapter where you spoke how, I believe it was you and your son were watching a meteor shower.
Oh, no, it was we were outside at night.
Yes.
Yep. Mm-hmm. In beginning of Chapter 2 of Beyond UFOs, I talk about my own little experience there with one, yes.
And you're still of the idea that it might have been just another one of the meteors?
Well, I think what's interesting about my personal UFO, and what this was, is we were out there at night, and we saw this thing that just over a period of about 10 seconds got brighter and brighter and brighter and brighter and brighter, and then it just disappeared suddenly. And so the question is, what was it? And so I like to use that as an example of how, in science we go about doing things, because certainly it could have been an alien spacecraft. It did exactly what I would expect an alien spacecraft to do if one was visiting. It, came in, took a look, but because their technology is so advanced, before I could really see what it was gone. That's exactly what an alien spacecraft, I think, would do. So to me, that's a real possibility. But scientifically, since I can't prove it was that, I have to say, what other possibilities are there? And another possibility is that was some sort of unusual meteor that happened to be coming straight at us as we were watching the sky. And in fact, we were watching a meteor shower. And so I would have to say, if I weigh those two possibilities, which one is more likely? Well, we know that, there's 25 million meteors coming into Earth every single day. So statistically, it seems more likely that it was the unusual meteor than that it was a spacecraft. But I don't actually know which one it is. All I can say is that, given my lack of knowledge, one seems perhaps more likely than the other. And so in science, all we can do with something like that is say, in that particular case, the answer is we don't know. And so one of the main reasons I titled my book Beyond UFOs is because that makes me think about the fact that, some people might say, I saw an alien spacecraft. Somebody else might see the same thing and be convinced it was an alien spacecraft. And we could argue about it all we want, but neither one of us can prove it either way. Whereas if we go beyond UFOs and look into the science, if Kepler discovers Earth-sized planets around other stars, there's no debate anymore. It's solid, factual evidence. And that's why I think it's so fun. Even if you're a UFO believer, it's still worth going into the science, because there we can come up with things that everyone will agree on. We won't have to debate. And if we get a real signal from SETI, then there's no more question about aliens out there.
You used a term that you also kind of touched on a bit in one of your chapters, and that's the term UFO believer. There's a bit of a movement among different UFO groups trying to get away from the term UFO believer, because that's more denoting a religious belief system and not a scientific research.
Right.
And I'm all behind that, because it's not a belief system. It's looking for answers.
That's right. And I think that it is possible to do scientific research to try to figure out whether there is anything that supports the claim that UFOs are here. And I think that it's great that people are doing that work. And I have no difficulties with that at all.
And I appreciated what you said in the book about belief systems and separating belief systems from looking for answers.
Right.
I found that quite refreshing from someone that is involved in the sciences and working to educate people on the sciences. I found it very, very refreshing. There was a question here in the auditorium I really wanted to get out here. There it is. This is from Dimensional Star, and she asks, how do you feel about the data denoting types of civilizations, and would you agree with them?
She's probably referring to the Type 1, Type 2, Type 3 civilization levels by the Russian scientist whose name I've forgotten. But I think it's just a way, that's data, that's not really data, it's just an idea. It's a philosophical thought about the types of energy use that different civilizations might use. And if I recall correctly, Type 1 is, you're using the resources of your planet, and Type 2 is you're using the resources of your star, and Type 3 is you're using the resources of our galaxy. So they're just ways of talking about the levels that different civilizations might have. The thing that I think is actually really interesting to me, and this is actually one of the major lines of thought that I talk about in Beyond UFOs, is if there are other alien civilizations out there, what stage of technological development would they be at? And when you take that fact that on average you'd expect a civilization rising up only about once every 50,000 years in the galaxy that I go through in Chapter 3, something like that. They're very rough sorts of guesstimates that I'm making. They're not based on solid numbers. But what you come to the conclusion is that if civilizations are common, and that's a big if, but I would tend to think they probably are. If they are, then there should be civilizations out there that are millions or even billions of years beyond us technologically. And that means that they've had plenty of time to colonize the entire galaxy. So my guess is that if civilizations are common, and again, my guess is that there are, then some of those civilizations have already colonized the galaxy, in which case it means we are right now surrounded by an incredibly advanced galactic civilization. And of course, it's not a new idea for me. This is exactly what Carl Sagan talked about in his book Contact, in the movie Contact. But I think what's interesting about it to me, when you really look at it scientifically, is even though we can't say yes or no yet, it's one or the other, certainly everything we're learning about the possibilities of life in the universe seem to me to be pointing in the direction of that's the most likely answer. There probably is a galactic civilization already out there. And that's an astonishing thought, because it means that someday we'll learn about their existence. And maybe, if the UFOs are real, maybe we'll learn about it sooner rather than later. Or if SETI makes a contact, we'll learn about it sooner rather than later. And that's why I'm excited about all the research that's done, no matter how it's done.
I appreciate that sentiment. I really do. Work of people such as Richard Haynes with NARCAP, who takes aviation reports and whatnot like that. But it's really good. And also on that index, that was in the posted in here, that was Michiko Kaku. That was his index. Let's see, there was another one here. Gemlight would like to know, how do you think space-time is affected by the mass of Earth and its spin?
Well, space-time is certainly affected by all masses, according to Einstein's theory of relativity. Masses curve space-time and respond to the curvature of space-time, so Earth has an effect, but it's the amount of your effect is strictly based on how strong your gravity is. And Earth, while for us human beings it's got pretty strong gravity, it's hard for us to escape it. On a cosmic scale, Earth is a very weak source of gravity, so its overall effect is quite small.
That's understandable. Excuse me. This was one that I was wondering. On SETI, what do you think is the possibility of them actually finding some type of a signal, intelligent signal, such as the WOW signal that was?
I mean, that's an excellent question. It depends on how many are out there broadcasting and so on. But, you can come up with different ideas. Seth Sostak, my textbook co-author, who, by the way, also has his own book out recently for the general public, he's willing to place bets that we'll get a signal from SETI within the next 20 to 30 years. I'm a little less confident than he is, but it's certainly a possibility, and the more we look, the higher the probability becomes, because if there's something out there, you have to search for it in order to find it.
True. Very true. And what's your opinion of the SETI at Home program? Does it help or hinder?
Oh, it's certainly a help. There is so much data out there that, putting all those computers to work on sorting through all the data to look for that, needle in the haystack signal, I think it's been a very successful program, SETI at Home. Even though there's been no discovery yet, it's allowed a lot more data to be analyzed than could have been analyzed otherwise.
this is true. I know quite a few people who have the SETI at Home program on their computers and run it quite often. Gosh, I kind of hesitate to bring this question up, but in light of a lot of the hundreds, if not thousands, of what are referred to as visual radar sightings of craft varying in size from the size of a Volkswagen to the size of an aircraft carrier. How do you look at that kind of a data and be skeptical of visitation?
I'm not necessarily skeptical of visitation. I'm just skeptical of particular claims. And I'm not necessarily even skeptical. I'm just waiting for solid evidence to come in. And, when it comes to these different sightings, I mean, certainly there have been some sightings that are very difficult to explain away, particularly when there's been something on radar or, a pilot has seen it, so on. There's plenty of these sightings that you can't explain away. But in the court, eyewitness testimony is never enough to establish, guilt or innocence. And in science, unfortunately, it's basically the same way. All the eyewitness testimony in the world isn't enough to make the case. We need something more solid than that. And so I'm not saying that I don't think there's anything to it. There could be. I'm just saying that, unfortunately, it hasn't risen to a level where it's convinced everybody yet. And I would love to see it do that someday.
Oh, here's another good question. Yes, there we go. This is from Gossamer again. He would like to know, do you think we should go back to the moon, possibly to establish a long-term base, or should we head for Mars instead, or maybe do both?
I actually addressed this in my book Beyond UFOs and also in my children's series, or I talk quite a bit about this. And yes, I think we should go back to the moon, and I think we should do that first. And I think we should go on to Mars, but I think we should do the moon base first. And there's a couple of reasons for that. And the big ones have to do with why we travel into space to begin with. And as a scientist, I'm obviously a huge fan of space science and actually, sending out our robotic missions and collecting the science and so on. But I don't think that as a nation we would be spending as much money as we do on the space program if it was only about science. I wish we would, because I think science is that valuable. But I think the real reason we spend as much money on the space program as we do is for political reasons. And, of course, Apollo is the classic example of that. We went to the moon to prove that we could do it faster than the Russians could. And we were successful in that. And I think that even today, the most important benefit of human space travel is its inspirational value to the world. And the moon has two great things going for it from that standpoint that Mars doesn't. And number one is that you can see it in the sky. And so if we can establish an international base on the moon where people from every nation are working together, then you can have kids everywhere on Earth looking up in the sky, seeing the moon and saying, look, scientists from all our countries are working together up there. If they can do it up there, why can't we work together down here? And I think that would have a huge impact on politics and children and education around the world. And secondly, I think for the long term, the development of space is going to depend probably more on the private sector than it does on the public sector. And I think one of the big things that the private sector will eventually do in space is space tourism. We already see that getting ready to start with the Virgin Galactic, for example, offering the short trips, suborbital trips over the next few years here. And when you look at space tourism, in principle, you could have great tourism on the moon. It only takes 2 days to get to the moon, 2 days to get home, which means you could go to the moon over spring break if tickets were available. Mars is a trip where it takes a few months, and once you get there, you've got to wait there for 2 years until it lines back up in its orbit with Earth to come home. And so 2-year trips are not an easy tourist trip. So I think the moon's got those two big things going for it, the inspirational value of actually being able to see it easily in the sky and the possibility of space tourism that, for me, make it worth going there first.
Well, I agree with you, and I would add another point into the going to the moon first and establishing a base on the moon, is it would be much easier to construct a craft that could make the trip to Mars on the moon, or even in moon orbit. I mean, you would be using less fuel to move so much mass.
Yep, and in my children's book, Max Goes to the Moon, that's the first of my children's series, we build the base on the moon. And then in Max Goes to Mars, they send the Mars mission off from the lunar base for exactly the reason that you're mentioning.
So I agree that we should go to the moon first again, and this time not stay for just a few hours and and then leave.
Yeah.
You know, I often wondered what would be the long-term effects of the lower gravity on the moon on a person. I know what it is. You know, zero gravity is in space and in orbit, but is there's this similar bone degeneration on a lower gravity, such as the moon? The moon's only like what, 1/6 the gravity of Earth.
Gravity. Mm-hmm. That's a very good question, and because we haven't been able to spend a long time on the moon, we don't really know the answer to that yet. Now, one thing though that makes me optimistic that it would be easier to deal with the things on the moon is because you do have that 1/6 gravity. You can, in principle, stress your muscles just as much as they're stressed on Earth if you carry around 6 times as much weight on your shoulders, right? Wear a real heavy suit, and that would still put the stress on your muscles. Now, your heart and the blood flow, your heart doesn't have to work as hard on the moon to pump the blood up toward your brain. So that probably has some physiological impact. But until we can actually start having people live on the moon for longer periods of time, we really don't know what that impact is. But certainly, people have lived in space for 6 months in weightlessness, and although they suffer some effects immediately upon their return, there's no evidence that it's had long-term implications, to their health and longevity. I think certainly living on the moon for at least extended periods, if not permanently, is probably fine.
Interesting. I mean, I never considered of the idea of putting 1/6 your weight on yourself to keep that muscle tone in
6 times your weight. Yeah, put that you need 6 times your weight to get up there. So that.
Oh, that's right. You're right. 6 times your weight. To keep your muscles going to prevent bone loss. I had never considered that, and that would be all that hard to do.
Nope.
That's an interesting idea. Let's see. We've got about 15 minutes left. Let's see. What's next? On your, excuse my paper rattling here. Oh gosh, let's see. Let me get these worded correctly. What do you see being the effects if say, a la the movie Independence Day, big craft comes down and settles over a city or over the UN or whatever? How do you see the scientific community reacting to something like that?
Well, I mean, certainly your first reaction is, wow, that's amazing, right? It just depends on what the intent is, and that's something that we can't really predict. Now, I think, where I would say Independence Day was off is we actually beat them, which is not possible. If they're got the technology to come here, it's like us versus an ant on the ground. There's no way that we would have a chance against them if they came here with ill intentions. But presumably, there's also nothing that we have that they really need, because their technology is going to be so advanced that they could manufacture what they need. They don't need to come here and steal it from us. So I think if we did have somebody coming in, it would be presumably because they decided that it was time for us to find out about their existence. And so now we're in the realm of the kind of thing that happened in Arthur C. Clarke's novel Childhood's End, or The Day the Earth Stood Still movie, things like that. And boy, it would be amazing if it happened. Guess I can't say much more than that.
Yeah, I agree there. I thoroughly agree. Without knowing what their intentions were, it would be difficult. And do you think that astronomers and nuts and bolts scientists can ever join efforts with ufologists to make a combined effort to study the UFO phenomenon?
Well, I think that if somebody's going about it in a scientific way, then in a sense the efforts are joined already. And I think the only difference that you ever see, again, I think astronomers, other scientists are just as interested in finding life and finding evidence of life, whether it's far away or right here on Earth, of alien visitation, as ufologists are. And the only difference there is sometimes in the way that we go about it and what we accept as standards of evidence. And I think that, realistically, science has been going on for a long time, and science has become very successful. It's what's enabled us to develop our technology by adhering to certain standards of evidence. And so I don't think that's going to change. But if someone in a ufologist comes up with something that meets those same standard of evidence, and I know that's what your goal is, then I don't think there will be any difficulty at all in working together.
Okay, and that leads up into my next question. How is it that you became, or was asked to speak at the upcoming MUFON symposium?
Well, actually, I don't quite know. I assume that somebody got hold of my book, Beyond UFOs, and liked it and wanted to have me come speak there. They may have heard me on, some of the other, I hear on your show tonight, something like this. I've been on Coast to Coast, and, a number of other programs like that. So I guess they heard about that and invited me, and I'm looking forward to it, especially since I live in Boulder, Colorado, so it's only about a 25-minute drive down to Denver. It makes it real easy for me.
Oh, you're just a neighbor to the north.
Yep.
And you'll be speaking about the contents of your book?
Yep, I will be.
Oh, awesome. So anybody who's planning on going to the MUFON Symposium this year in Denver, there's an opportunity to meet Dr. Bennett and be able to talk with him about his work and learn more about his work on this book. From what I've read, it's a very good book. Like I said, I have to admit, I didn't have enough time to get it finished. But from what I have read, it is a good book. And I'm a discernible reader. I don't just just go, oh, it has UFOs on it, it's got to be good. No, I'm not that way.
Well, I think if I can give you a little plug for it.
Sure.
The Miami University of Ohio every year chooses one book for all their incoming students to read, and over the past 20 years, they've picked books by Kurt Vonnegut, George Orwell, Toni Morrison, Dave Eggers, people like that, and Beyond UFOs was their selection this year for all their incoming students to read.
Oh, boy, you're in a real prestigious group of authors.
I was quite excited to see that happen, yes.
I've read quite a few works from quite a few of those authors myself.
They were looking for something with a science theme, and I think they liked the fact that it took not only the scientific parts, but that I also go into the philosophical and humanistic implications of the science.
So I also read in here a section on how you see mankind not treating the planet very well. And
that's right.
The way we're getting into this global warming, and all that. And
well,
I thought, well, good for you.
Thanks. When you get into that Drake equation, as we talked a little bit about before, really the biggest factor we think, based on all the other probabilities that I talked about, the one that probably determines whether there are other civilizations out there right now, whether there's a galactic civilization around us, is whether any or all of those civilizations survive past their adolescence. And I say that we're adolescent right now. We're in that stage where we can't quite reach out to the stars. Our technology's not there yet, but we're starting to take the baby steps out to the space station and the moon and so on. And so the question of whether we can survive from adolescence into what you might consider adulthood civilizations is a question of whether we are able to survive. And global warming is probably, maybe after terrorism and nuclear war, the biggest threat to our long-term survival. And so how we deal with that and understanding it is an important part, not only for ourselves, but also for our understanding of whether other civilizations have been through the same thing and gotten past it. Because if they have, then they're probably out there. If they haven't, if these are things that everyone succumbs to, then they're probably not out there.
Oh, here's a good one. This is from Joseph. He says, I wonder about SETI in that we would only be able to listen to a civilization at or about our level, since at first our radio transmissions were at low frequencies. Most of our transmissions are less than 1 gigahertz. We really should listen. Go ahead.
Yeah, that's a very good question, and I think there's, number one, civilizations presumably would have to be at our level at some point, so you would get the signals that they sent out when they were at our level. But then, if they're really trying to make themselves known or broadcast or wait for somebody to reach the right level of technological development, as Carl Sagan talked about in Contact, then even someone who's far more advanced and doesn't use these technologies for their own communication anymore might still be sending out signals with this so that primitive folks like us can detect it. So I think there's a lot of hope for SETI to have a real success.
Just out of curiosity, excuse me, on what kind of a frequency range would be considered just interstellar noise?
I don't think it's the frequency range so much. It's the actual signal that you're receiving. People have made guesses early on because we could only listen to one frequency at a time. They made guesses about where aliens might broadcast and listen to those particular frequencies. But the new efforts are designed to scan millions of frequencies simultaneously, since we really don't know what they would use. And again, we're looking for something that has a pattern to the signal that makes it stand out from the natural background, whether it's prime numbers or something else.
And I read somewhere, and don't ask me where, because I don't remember where it was, because I've read so many things over the course of the last few years, that the SETI program has, in its charter, I believe it is, a provision that if a intelligent signal is found, what the procedures were of reporting it and what the procedures were on letting the public know. And it's the decision of letting the public know is all out of the discoverer's hands. It's a committee decision. And even then it has to be approved by the UN, if I remember correctly.
Well, the UN would not have anything to do with it at all. It's completely a private enterprise. I don't believe there's anything in the charter that says anything like that. What they have worked on at SETI is they've had meetings and discussions about what kind of protocol you should follow to, announce a discovery. Now, in fact, much of that has been rendered moot by the spread of the Internet, because they did that work back when, you actually had to go to the media and make an announcement. These days, everybody's going to hear about it over the web before anybody gets a chance to sit down and decide what's the best way to release the information. So I think that the information is going to get out there pretty fast once it happens, if it happens.
In your opinion, from what area of our galaxy do you see a signal coming from, or signals?
Well, that's a good question. I think that, there are people who think that there's only certain regions of the galaxy that are likely to be habitable, the people who have these ideas that we sometimes call the rare earth ideas. But I personally, and I go through in Beyond UFOs, why I find those ideas, even though I think they're interesting and they're possible, I would tend to bet against them. So I think it's possible for there to be a civilization almost anywhere in the galaxy. So I think it could come from any place.
Okay, we have just a little under 3 minutes to go. If you'd like to tell again the name of your book, where they can get it,
well,
any other speaking engagements you might have coming up.
Thank you very much. Well, my book that we've been talking about tonight is Beyond UFOs, The Search for Extraterrestrial Life and Its Astonishing Implications for Our Future, and you can look at some excerpts from it on my website, beyondufos.com, and you can get it at most any bookstore or Amazon. From my website, you can click over to Amazon to get a copy. And then I also hope everyone will take a look at my children's books, Max Goes to the Moon, Max Goes to Mars, and Max Goes to Jupiter, which you can also link to off of there or from my personal website, which is www.jeffreybennett.com. And I'll be speaking at MUFON in Denver on, August the 8th, I believe, Saturday, August the 8th. And that's my only speaking engagement that I've got on the calendar in the near term right now, but I'm sure I'll have quite a few more in the future.
Oh, would we be able to keep up with those on your website?
I try to maintain the events page on my website, but sometimes I forget, and I forget to put something on there until after I've done it. So, but hopefully it'll be up there.
Oh, then you need someone like David, my husband here. He keeps my website up to date. He's my webmaster, my media director, my research partner. I don't think we can get along without each other.
Yep, excellent.
He keeps me well organized. Well, and on that note, unfortunately, we are all out of time. 2 hours just never seems to be enough.
Well, thank you very much. I've really enjoyed it.
Well, I appreciate you doing the program with us tonight, and I'm sure my audience enjoyed it as well. And, well, if you get another book coming out, let me know, and we'll get you back.
I'll do that. Thank you.
Okay, and unfortunately, that's all the time we have for tonight. I want to thank everyone for tuning in, and also to thank those who joined us in the Palcock Auditorium, and also a special happy birthday to you, Kevin, many more. Stay tuned for Voice of the People, hosted by November Hansen. Tonight, her guest is author Stephanie South. And please join us again next Saturday on the UFO Paranormal Radio Network for another episode of Eye to the Sky, the UFO Synopsis, where my guest will be my dear friend, Peter Robbins. Until then, keep an eye to the sky. Good night, everyone.